Hello everyone, this is Ch.suhas bharadwaj from BIT Mishra. Today we want to discuss about the basic function of operation amplifiers and what the need of operation amplifiers and whatever the funda it is. Okay, without any further ado, let's get started. Okay, what it is mean by operation amplifiers? The term operational refers to initially they want to do mathematical operations such as integration, differentiation, and also subtraction and addition. Mean at that time there are no digital computers, only analog computers which will do mathematical operations. But now even nowadays it can be used as a mathematical operator. These operation amplifiers use it for such as integrator, differentiator, also summer and the subtractor. In the operation amplifier there are two terminals, the positive terminal and the negative terminal. The positive terminal, which is called as non-inverting terminal, and the negative terminal is called as inverting terminal. And there are two upside and downside. These are called the internal voltage gains, which are used for the amplification, means modulating of the input signal. These are two power supply positive and negative pins. Okay, the op amp is just an amplifier used for math operations. Means this is used as a differential amplifier, as two inputs and one output has some gain, and amplifies has gain. Means that is the main motive of the amplifiers, which can modulate the signal using gain. The main motive of the operation amplifier is nothing but it takes the difference between the operating and inverting and non-inverting terminal, and with the internal voltage gain it amplifies the signal. That is what it is. But even though operation amplifiers looks like it used as a differential operator, but it don't use as differential operator because there are some rules and regulations behind the working of an operation amplifier. Let's see what are the rules and regulations behind the working of an operation amplifier. See, the third rule says that operation amplifier gain is very huge. Means the operation amplifier, what do we say? Internal gain is almost very huge. It almost tends to positive infinity. Suppose let's see here. There is a non-inverting terminal has 1.01 volts and the inverting terminal has 1 volt. And with the huge gain in the internal, very huge internal voltage gain, the output gonna be very huge. Means with hundreds or thousands or even millions. But the circuit is only capable of some 5, 10, 15 volts. That's it. So what's gonna happen is if the larger terminal, if the larger voltage is the non-inverting terminal, it is gonna saturate to the V plus. But if the negative means inverting terminal has somewhat a little bit of high voltage, then it gonna it gonna saturate to the negative, V negative. So that's it. It also can be used as a comparator, not as a essential comparator, not as a designable comparator, but it's also compared as a crude comparator, not a design comparator. That's it. What we have discussed until is the basic part of the operation amplifiers without any negative feedback. Negative feedback means external circuit. So now let's connect the negative feedback, means the external circuit. See here, RF means feedback resistance, and R1 is the resistance which is connected to the ground. Until now what we discussed is the open loop configuration, means there is no negative feedback. Right now there is a negative feedback, and this one end will be connected to the AC signal or a DC signal. Operation amplifier can hold both. So one end connected to the, this is here, it is non-inverting terminal, it is connected to the AC source. It is called a single-ended amplifier, which can connected to the only only one terminal connected to the AC or DC source. With this negative feedback it became very hugely useful and powerful. Okay, what it mean to be, let's see. For working of an operational amplifier connected to the negative feedback, there are some certain rules. See the rules. The rules are no current flows in or out the inputs. Also, the operation amplifier tries to keep the inputs the same voltage. Means what it means. No current regardless how you connect the circuit. Means how you connect the circuit up. Open loop comparator or whatever it is. Open loop comparator can't use this rule as it don't have negative feedback. And the second rule says that the op amp tries to keep the inputs the same voltage. This rule is only applied to the closed circuits, not to the open circuit, as it has no negative feedback. It says that whatever it is only applies to the closed loop. Op amp can't change input voltage by drawing the voltage, but it can do with the negative feedback. Only closed loop with equal inputs. Rule number one says there is no in or out current. See, there is no in or out current in both the inverting and non-inverting voltages. And the rule number two says that the op amp tries to keep the voltage same. I mean, see here, what the voltage in the initial, I mean, here it is non-inverting, it needs to be same as the inverting. But in the see here in the open case, there is no negative feedback connected to it. I mean, operation amplifier can't change the initial input by its own. It can change through its negative feedback, not its own. So the need of it is the negative feedback. It can change, it can make the this negative, I mean, this inverting terminal as voltage as non-inverting voltage through the negative feedback, not its own. Now let's look simple configuration possible with no external components. This, see here, it is. There are no RF, I mean there is no feedback resistance and the no resistance which is connected to the ground. Here you can see that if we take the, suppose we can take the DC source of 1. We can take DC or IC. It's DC comparator. I mean you can take whatever it is. Let's take DC 1 volt. The second rule says that with the help of negative feedback, it's gonna make the second other input signal even 1 volt, not but not its own. See here, so the gain is needs to be 0, so that it came out the output same as the input, and also came to here as 1 volt. That's it for the rule number 2. This circuit is called as a buffer as there is no internal gain, and gain is equal to 0, so it's called as a buffer. Means, well, rule number 1, no current flows through the any load across the non-inverting, like some sort of sensor or feeding pulse with modulating signal from microcontroller with low pass filter or whatever it is. No current is gonna input in operation amplifier, doesn't disturb sensor or circuit. You can observe as input works as very high input impedance, and the output works as a very low output, low output impedance, high input impedance to low output impedance. Means in this here it can drive things with very little, very sensitive input. But in the after the simple case, let's take this case. If we take the negative feedback with some RF, with feedback resistance and the resistance connected to the ground. See here it feeds, inverting input is taking small portion, this RF take the small portion of voltage. It acts as a voltage divider. And in always case, every case, remember that RF greater than R1. Feedback resistance is always greater than the resistance connected to the ground. And this is what essentially the negative feedback means. Negative part of the output and the feeding it to the input. Very simple form. Okay, for see, for inverting operational amplifiers. See, it is gain. It is the internal gain. Internal voltage gain equal to RF. Let's say internal voltage gain is AV equal to RF by R1 plus 1. We know that always RF greater than R1. So let's say if the RF equal to 9 kilo ohm resistor and R1 is equal to 1 kilo ohm resistor, the gain is to be 9 by 1 plus 1, which is 10. Means we apply the input, if we apply the DC source of like here in the non-inverting terminal and 1 volt, it come out to be with gain of 10, it come as 11. It is what it mean. These are the basic buildings of modern electronics, and as we get positive negative rails which we will get can feed AC and DC signals. About ground, it can feed negative. Even if it connect as negative 1 volt, it come out as negative 11 volts. Okay, that's it for today guys. Thank you.